All right, so this is for Thursday, October the 22nd. And so right now it's October 23rd, Friday afternoon. Remember, Monday, Tuesday, Wednesday, Thursday, those Zooms, those rapid videos should be available by 4 or 5 p.m. that afternoon. But Fridays, whatever the last day of the week is, in this case it was Thursday, would come later. It would come Saturday, probably by Saturday, 1 p.m. Depends on what's going on, whether I'm camping or whatever. But the Friday Zoom is going to be, or the last day of the week, that's going to be long. Until this time, I had parent conferences Thursday night, Friday morning. So I'm just now getting around to doing the Zoom. Okay, so just letting you know, timing wise. All right, I'm going to pause this and set up the other screen. Oh, and before I share the screen, I have lots of these. I have your packets. This is a few. I went through all the ones. These are the only ones I didn't get to yet. And all I've done so far is to look at the notes on the back. Or if you turn in a notebook, I've looked at your notes and I've given you credits. So you get credits for notes. I think the most credits anybody got, I think was like 30 something. Now you need at least, I think it's 9 or 10 credits. I'll get that. I'm going to look through these to determine what I consider a reasonable amount of notes. And then those reasonable amount of notes will get 34 out of 34 for the notes. And then if you take less than that, if you don't, and 3 credits is about 1 decent page of notes, not too dense. I've had one girl, who was it, Aspen, I think, that was getting up to like 5 credits for a page because her pages are well organized and they're pretty dense, maybe even 6 on one of them. Most credits I've ever given 1 page of notes is 10, but this student would take notes. He's now architect, but he'd go back and redo his notes at night. He prided himself on getting them onto 1 or 2 sides and really well, and it would take pictures of them. We used to make note cards back then too. He'd do the same thing with his note card. Just amazing. Michael Romero, I think Michael Romero was the one that could do the note cards, and Casey was the one that could do the notes. So anyway, it's a skill. The point is, you might just get a half a credit per page if all you're doing is you wrote one little equation on a page. That's probably that isn't even worth 1 credit. So you get points, you get credits, and I'll go over this Monday in class, but this is mostly for virtual kids. So when you're doing your notes, you get credits by organization. It helps when you date. You put dates on your notes. You put your name. I had a couple people turn in some great notes, no name, and it wasn't attached to a packet. So it's like it was in a notebook, but I don't know whose notebook it is. So you have to actually, when you turn stuff in, it's a good idea to put your name on it if you want credit for it. Should be the first thing you do is put your name on it. Anyway, so always do that because sometimes your notes get detached from your packet, and then 1 page falls off, and then I don't know whose it is. You get no credit for it. So I know you may not like writing your name, but put your name at the top of the pages. If it's a notebook, just put your name somewhere at the front of the notebook. Anyway, so, and normally we have a certain kind of notebook, the laboratory notebooks, and they're really nice, but couldn't afford them this year. District couldn't, so it was a hodgepodge. And I got composition notebooks, I got loose paper, I got some real nice notebooks all over the place, journals, everything. And I guess I'm just going with it. It's up to you. But so saying all that, just letting you know that your notes are being graded, and all those grades won't come in until I grade the packet as well, because the packet and notes, those scores come in together. And usually they come in either at the same time or right after the test, because the test, 300 points, for a lot of people, it just makes the grade go, so you need a little more. I have that cushion in there. And I'm not against maybe even beefing up the cushion a little bit. The cushion's sort of like the federal deficit. And then it's got to go away at some point. I mean, I've never finished a semester with kids that actually had an active cushion. So it will go away, but I'm trying to give you a chance to build up points on notes and notebooks and, on packets and things like that, the keys are posted and you should be acing theoretically. There's no reason why you shouldn't ace a packet if you have all the keys posted too. If you have to go through and check and correct stuff and fix it, maybe even add stuff, then do it. That's what it's there for. Okay. Your score should only be hit by these initial tests. And then we'll do some black and blue somehow. I don't know how, but I know how to do it in class with black and blue points. And black and blue points the blue points on some problems are considered blue problems on tests. And you can get half the credit back on those. And then occasionally, not every time, but occasionally, some problems are nobody got it. Like I overshot my mark. And those are considered black questions. And those you can redo for full credit. But you have to redo them. You just don't get the credit. You got to, and with a key and help and all that, probably a help video or something. Okay. Well, and I really enjoyed talking to parents that Zoomed in. It was all Zooms. And I set up my own little appointments. I sent that long email to everybody. And then on that email said, hey, if you still feel like you need to talk, then email me and we'll. And so some parents did. And so we talked about, students, and my perspective, your perspective. Now, if you're virtual, I don't have a lot of perspective. Well, I see their name on screen and they have a really nice name. Yeah. So most people that are virtual don't interact. And what I noticed today with my virtual kids and yesterday when they were taking the test, they were coming in to take the test on the picnic tables, we had 15 feet between people and all the windows up, window open and fan on. I still have like 9 people that got to take it. I think 7 of those are virtual. So we got to get that done. That's going to end up being a 0 eventually. So you've got to come in and take it. Not come in necessarily. I mean, you can, I don't know. I mean, you can come take it and sit in my driveway if you need to, if that's what it's got to take, or I got to bring it to you, whatever we got to do. But you need to take this. Now, next time with test 2, which will be towards the end of November, this is what I was telling parents, because, it's tough on them. If your kid's only 15, you got to drive him to school, and one poor kid, Noah, had to sit in his truck today after he finished his test. He sat out there for like 20 minutes because I was talking to a parent and then I just kind of forgot. So then he stands out in the cold. So it just wasn't, it's too much. It's too much work. It's more work than I thought it would be to give a paper pencil test to a virtual student. So we got to figure that out. In class, it'll stay the same. But for virtual, I don't know how we're going to do it. Okay. So I'm talking a long time. I'm just trying to get all this stuff out there. One, because it's my chance to, talk to virtual kids. Well, Monday night, we'll still do our Zooms, and I'll probably repeat myself Monday night, 9 to 10, same Zoom channel. If you get on there on the, and I'll do better on putting even though you've been to the Zoom a lot, you've been to a lot of Zooms. So I'll put the Zoom address or the ID number on the front of the canvas in that table. Those details out the week. I haven't done that yet for next week, but I will. And then I will, I may change the password. It's been ASCII Zoom for a while. It needs to be something new, something so that in case somebody, let's call it, how about ASCII Zoom 2? Ooh, ASCII Zoom, ASKEY ZOM. I don't know if the Z is capitalized. I guess I'll capitalize it. Capital ASKEY, capital ZOOM, and then the number 2. Okay. And then maybe, so packet 2, that'll be it. And then packet 3, we'll switch to number 3 or something. Okay, we gotta switch it up there once in a while. So that'll be the new, I'll fix that when I get done here. All right. So let's go about the parents. The parents can, they can come in, but they can Zoom me anytime. If they go, hey, wait, we didn't Zoom him. We wanted a meeting. Well, then they didn't get that email, because that email I sent out said, email me. Or they didn't read that far. It was a very long email. I apologize for that. But they can they can email me anytime if they want to talk. And we can set up a Zoom, or we can just talk on the phone. I don't like talking on the phone. I'd rather just Zoom. At least I could see you. If they're willing to show the video of their face, if they're willing to show a video, then we can Zoom. Otherwise, I don't know why we're Zooming. I'm Zoomed with a couple of parents. They didn't put their picture up there. So why don't we just make a phone call in that case? Well, I get it. You can see me, but I can't see you. I don't know if I like that too much. So that should have just been a phone call. Anywho, okay. So that's all that I have for right now. And I'm going to now switch over to the slides, and we'll talk about what happened on Thursday. It was a very good day in class. I got the best students. Wish, man, that's what I was going to say earlier. I wish my virtual kids were in class, because, man, they're good. They're looking at their notes and stuff. I'm telling you, these virtual kids, the cream of the crop, you know. And we got kids in class that are just cream of the crop. So really hardworking and thoughtful kids. You know, I mean, if they were in class, man, we would be, can't tell you, we'd be in this stuff wandering around. We'd be having so much fun. Okay. Anyway, so let me pause this, and well, let's go ahead and share the screen, I guess. Ready to go, yeah. Okay. So this is class number 7 for packet 2. And I just, it's on Thursday. You're right. This is Wednesday, because Thursday was the test. So test was Thursday. So that's why if you're looking for Thursdays, you're not going to find it. So it has been a while since we did this. It was Wednesday. Oh, well. Now, this is something that Io pointed out. Another virtual kid, Io pointed this out, that yeah, you can write the equation for 4, and this is off 2.1. You can write the equation for it, but it's notice I got to update it. This thing is, here's the thing, I did update it, and then when I went to make copies of it, I was in a hurry and I grabbed an old version. It's like, so now I got to sit this another year. Hopefully next year, my last year, that it'll finally be updated. Okay, so why are we getting nothing? Okay, so this 4, you can write the equation for 4, but then the graph is a little funky, and if I hadn't had that kind of highlighted in or thickened in, it wouldn't have made it so funky. But because the graph has that right there, it makes more sense just to make it north, change it so that the marina is north, not south, okay? And that makes your graph make more sense. I mean, if this is the first quadrant and this is the 4th quadrant, you know. Now this sheet, the whole sheet is due on Sunday, at the sheet this is on. It's due Sunday at midnight. I've already got students turning it in, and that's great, but you have till Sunday at midnight. It's only worth 20 points, which I say only because, you know, we just had the 300 point test. Okay. So I showed the kids these notes. Here's Natalie's from 3rd hour, her notes. And in grading your notes, I found some fantastic notes that would have benefited so many students, but for some reason, you sat on top of it and never turned it in. Never turned it in early, and maybe because you didn't know. Well, I made a plea over many times to please, if you have great notes, send them to me. Take pictures of them. I'll take pictures of them. I probably prefer that you do it, but you got to do it with the right lighting and all, okay? And so I can read them. So I'll take pictures of them if you want me to. So the thing is that I had so many turned in that were wonderful, but what good does it do anybody now? I mean, maybe for the final in December a little bit, but students could have benefited from your skills a couple nights ago when they were trying to figure out and trying to get some notes themselves and trying to study for the test. And if they had your notes, you know what I'm talking about. I mean, if you get a bunch of bonus on your notes, then you should have turned yours in. So here's what I'm doing. I'm going to give you an extra 10 points on your notes, if you will. I mean, Joe Smo turns in his notes and they're awful. And he goes, okay, where's my 10 points? No, they have to be, maybe show them to me. And then if I say, yeah, those are great, we should turn them in, then you'll get 10 extra points if you turn them in at least 2 days before the test. Not before the test is too late, really. 2 days, at least 2 days, maybe 3, preferably 3 days before the test. Because we always finish the packet, then there's some not dead time, we go on to the next packet, then there's the test. So you always have, when you're done taking notes, but we haven't taken the test yet, that you could then turn your notes in. So up to 10-point bonus tacked on to, plus you're going to get bonus because you have really good notes. Some people got bonus on this one just because they took voracious notes. I mean, I think Alex wrote every daggone thing down. I mean, I'm not saying they're really readable maybe for Alex, but I was impressed by his a lot of notes, And some of you taking notes on thin paper, and then you're writing on both sides, and then it bleeds through, and then those notes you can't take pictures of. So if you're writing in picture ready, then you need to probably keep it on one side of a page. Now, in my thick notebooks that I give you, I think a couple of you, I said, hey, you want a notebook because you did an amazing job. But if it's my thick pages, then those won't bleed through. But most thinner page notebooks still bleed through. So one side, there's a reason. If you got a cheap notebook, there's a reason why it's a cheap notebook. Paper's cheap. So now those notebooks, I would just do one side. Okay. Now these notes that Natalie took here, they were in my notebook. They were in the notebook that I gave her. So, yeah. Okay. So here we go. Make that offer. So physics review, we talked about this in the last wrap up. I went into a lot of details on this. So look this over. This is a derivative graph. Now, I went ahead, the derivatives come from these flat lines. These numbers in here are the areas of these rectangles. And the area represents, if you look at this, and I know I repeat myself, but sometimes people haven't watched every video. So this is velocity in meters per second. This is seconds. So I multiply these two together, meters per second times seconds, the seconds cancel. I'm left with meters. So the area then, since the height is meters per second and the width is seconds, the area ends up, oddly enough, being meters. So it's a weird case where area equals length. Think about that. In this case, area equals displacement. So it equals an arrow. An orange would be an orange arrow, I guess. That'd be an arrow that is pointing positively. Purple would represent a purple vector that's pointing back. And this is velocity vector. Okay, so it's telling you which way you're going and how fast you're going, whether you're going backwards or forwards. So there's a lot. This graph is very descriptive, actually. It's telling us, it's a choreography of what happened up here. What happened, what I did in the hallway. I could give you this. And in fact, I'm going to do that. I give you something like this, and you have to act it out. That's coming here next week, like early, like probably Monday, Tuesday next week. This will be your choreography. We'll be acting this out. So it's good practice. Sometimes kids do it with their fingers. It's called finger dancing. This is coming up here next week. A little preview here. I have had people go out in the hallway and do it. I've had people that did it as groups. You can't really do that now, unfortunately. Maddie did it as a ballerina. It was really, really good. I have that on video somewhere. As a dancer. I mean, she didn't have her tutu on, but she danced her way through this choreography, which is awesome. So you should be able to give a paper like this, and it tells you how fast to go, it tells you what direction to go, and it tells you how long to do it. And that should be enough for you to visualize this. Okay? That's what you got to start doing. That's thinking like a physicist and who does calculus, because what I'm talking about here is integration. And if you take calculus, you'll spend about a semester, if you're lucky, doing derivatives. And then when you get to integrals, you'll spend about 3 semesters doing integrals. That's what OU is. It's 1 semester of derivative calculus with some integrals thrown in, simple integrals. And then it's 3 semesters of integral calculus if you're going to go all the way to Calc 4. Okay, so that's the warm-up for this. And here I am about 25 minutes into it, and we're finally getting into the new stuff. I ought to have something that comes on the screen. New stuff, so that you can fast forward. Maybe that'd be smart, like in the description, kind of give a little table of contents. So, okay, I hear you. And I'd put that in the YouTube channel description, so you can fast forward if you don't want to see announcements. Okay. Maybe that's all you're going to see. So this is the back of 2.3. That was Crazy Joe we're looking at, wasn't it? That was crazy. I'm sorry, that was Slappy the Clown. Yeah, that was Slappy. That wasn't me in the hallway. That was Slappy the Clown. But this is the back, and the back of 2.3 has got nothing to do with Slappy the Clown. So a different situation. So remember I told you that this graph down here, this is the V versus T. Remember I told you there's your divider between forward and backward. This is the choreography for what you're doing. Well, look at that. There's a guy and his wife, Dick Henry, Dr. Henry. He lives by me, and he's kind of the head of the astronomy department at OU. He's retired now. He still goes into the office some, but brilliant man. I had his kid like 20 years ago. No, probably close to 30 years ago. I had his son and his daughter. Being great kids, swimmers and stuff. Anyway, Dr. Henry's wife are just lovely couple. But anyway, he's the guy who started these astronomy nights that we would go to. We would bring, Norman High would bring like 80 students, whereas we would have as many kids there, and they were good kids. I mean, they listened and they asked questions at the end of these lectures. And then we would take up about half the auditorium. Well, okay, a third of the auditorium. It held 240. So we'd take up about a third of the auditorium. And I was always so proud of those kids. Anyway, so Dr. Henry just walked by. We saw him out there. Hopefully we'll get to do something like that again. We had something going. We had a whole series, and Eileen Grabowski at Norman North is one of the main. I don't do much anything. I just kind of, if you tell me to go, I go. But they brought in so many good people, and now they can't come. So maybe they'll switch this to 2021, and we'll have that great lecture series. The cool thing is you go up and you listen to this really, these are all over the nation. These are like top researchers talk about interesting things and about astronomy. And then at the end, you get to go outside, and at night, it ends when it's dark, and you could look through the telescopes at Jupiter and Mars, and if Mars is rising, the moon, and all this cool stuff. Saturn, even, they had really good telescopes out there. So hopefully that'll get going again. That's just one of those horrific things that COVID's taken away from us. I don't want to think about that. All right, so here we are. I guess we still have our physics, though. Even though COVID took everything else away, all the fun, all the ping pong and foosball, and just the robotics and the rocketry and all the things we do, and the puzzles and the chess, cantina. At least we still have our physics. Okay? And they cannot take that away. As long as you have a good YouTube, good internet, or just a good book. All you need for physics is a good book and a brain. All right, so here we are. The green represents, and I color these in, and once again, you need to have colors with you. You need to, if you're watching me on the screen, watching this, you should now have filled in the forwards areas as green, or a color, and then fill in the backwards area as another color. So if I look at this, I see the choreography. I see something that's running out away from the origin pretty quickly. I mean, look at this. This is Usain Bolt speed. So it's running away from the origin at 10 meters. Sorry, man. Oh, what? Thai food. 10 meters a second for 8 seconds. Okay. Then turns on a dime, which, by the way, is impossible. But this is a step function or a subset of a piecewise function. And piecewise functions are impossible. Why? Because they create what's called diffraction points. This is a virtual special. I didn't talk about this in class. I'm a little more relaxed at home. There's not 10,000 things in my mind. So I can just think physics. But the reason why these are impossible is they cause diffraction points, and I'll show you those in a minute. But you cannot go from positive velocity and instantaneously switch to negative velocity. There has to be a fade out and a fade in time. Okay, so that when you do those fade out and fade ins, that means a curve, which actually, finally, believe it or not, we're getting to Tuesday or Wednesday next week, probably Tuesday. We'll start that lab. It'll be I've scrapped the old labs that we were doing, which was fun, but time consuming, but it forced you to kind of be too close. So we're doing this other one that's okay. It gets the job done, but we'll be out in the hallway Tuesday. It's a nice little lab. So anyway, it'll spring forward to a whole nother way, a whole nother level up of physics. Okay, and much more real. So anyway, so the green is we're going forward. The purple is, and I'll try and bid it for you virtual kids. I'll videotape it without trying to show kids' faces. The green is the forward. The purple is the back. So if I'm looking at this, let's say I had 10 seconds to go. The time's up on the test. The teacher's standing over me. I got 10 seconds to go. They're wanting to grab my test out of my hand. So I'd say, okay, I look at this. I'm going steep up, shallow, a little shallower down. And then what's going on right here? Aha, that's nothing. So this is flat. So 0 here means flat up here. Linear here, flat up here means linear up here. And then we go up again, and then we come back down sharply. So I would sketch this out with if I had 10 seconds to go, I'd say, okay, I start there with the or. I'm just trying to get some points. That's where you treat all the points you can get. So I'm going to go up like that. And this is true for the AP exam as well. I'm going to come down, not quite as sharp. I'm going to come down, and it looks like I'm going to flatten out here. Then I'm going to go up again. And then I'm going to come down again like that. So it's going to look something like that. So in your mind, you can visualize what it looks like. So you're not just going blind here. Now all we got to do is come up with the right exact numbers. Okay, so now we have to go through and now keep in mind with this is called a duet. And on these duets, going from lower to higher or higher to lower, the time is always the same. Times correspond. So that's one axis you don't have to worry about. So this will be 10, 20, 30, 40, 50. So there's my time. And then I'll look at, now I need this, thing is I need this table because I don't know. I mean, a big thing we talk about in class, and so I'm going to go ahead and do this. You'll need, well, okay, I'm going to white out some space here. Blow this up and white out. I'm going to give myself an arrow. All right, so a big old fat arrow here. And this, go a little further even, real fat. So in general, here's a huge, this is a big calculus concept that I didn't realize when I first took calculus. And I thought I was pretty good at calculus in high school. Teacher used to leave and I used to have me teach the class. He'd go out and smoke a cigarette. Oh, Mr. Youngers. At least that's what I thought he was doing. So this represents accumulation of, in this case, position. So as I'm going left to right on this graph, on any kind of, these are called intervals. These are all intervals. We have positive, negative interval. But as I'm going left to right, I'm accumulating position. So these are all tied together in that way. If it was money, and you do derivatives in money all the time, right? This is called a derivative graph. And so you do derivatives on Wall Street. But same kind of concept. But in that case, for money, it's like accumulation of wealth. But in this case, it's accumulation of position. Okay? So that's a big, if you got that concept, good. You're ahead of me when I was a freshman in college. So I'm going to accumulate this, and this and this will show, this is like, if it's a money situation, this is like how much money you've earned here, this graph. Like this is your first week, second week, third week, fourth, something like that. In this case, though, it's not how much money we've earned, it's how much position we've gained or lost. All right, so we start off with these. Now, remember I said this is 80. This guy is 10 meters a second times 8 seconds. So it's 80. Getting ahead of myself there. So this area here is 80 meters. 80 meters. Let me carve out some decent little dots here so I can write in these. Every one of these you want to do this with, and you don't need to carve it out like me, but this is a key, so it's supposed to look nice. Okay, so here we go. Okay, so this is 10 meters a second times, so V times T, right? And we know that V, we know that V times T equals delta X. So multiply them together, and I get a delta X of 80 meters, okay? Come over here, and now we look at this guy. Now on this one, I'm going backwards at 5 meters a second. So I went out 80 meters, and now I'm back. I turned around, I'm coming back. Maybe there's something called Girl in the Jeep, which we'll do that later, I hope, unless I skip it. But she goes forward, now she has a reverse and she's backing up. So at 5 meters a second, and she does that or me, I do that for 17 seconds. So 17 times 5 is negative 85. So they backed up, this is purple, Let me find my purple here. Okay, so it backed up negative 85 meters, or turned around and ran back. Okay, so on accumulation, let's go back to accumulation here. I started off 0, 0 up here. When I'm filling that table in. And then by 8 seconds, I'd gone out 80 meters. So I'd accumulated 80 meters of position. And then I started turning, I came back. And so I lost, by the time I got to 25 seconds, I had lost 85, which puts me at the negative 5 meter mark. And then look what happens for the next 5 seconds. See, nothing. And so I'm standing still. And so I'm also at negative 5 meters at the 30-second mark. Well, then I get a burst of energy again. I go forward, or whoever, the girl in the Jeep, she throws it forward and she takes off at 7 meters a second. And they do that for 15 seconds. Well, that's 105. That is, if you multiply it out, it's 105 meters. Then throws it in reverse, backs up at 10 meters a second for 10 seconds, and that's negative. Even I can do that, negative 100 meters. Okay. So we go back to my accumulation table, my T-chart, like you had in math. And so we say we're at negative 5, and then I added 105. That puts me at 45 seconds. I'm up to 100. I don't know why I'm doing that. I don't need to keep putting M's. I mean, it's dumb, because I already have an M up top. I don't like to do work I don't really have to do. And then at 55 seconds, I drop 100, so I end up back at 0. So now, once you have that accumulation chart made, you don't need to go back to the graph down there anymore. Now you can go up and plot this. Looks like for position, we don't want to keep, I don't want to make this 0, 0, right? Because then that would take me off the graph. I do spend a tiny amount of time in the fourth quadrant, see, the negative 5. So I'm going to make this point here 0, make that my origin. This is X in meters. Okay. So make that my origin. And then I have 20, 40, 20, 40, 60, 80, 100. Okay, seconds. Anyway, you get it, 80. Close enough. Okay, so now all I gotta do is plot my points. So I do that. I'll plot those in purple. So I got 0, 0. I got 8 over, 80 up. Ooh. On my first peak. And then I go 25 over, I'll be at 5 down. And then at 30 over, I'll still be at 5 down, 5 below or south of where I was. It's not really saying whether this is a profile view or well, it's not really a view. It's a duration graph. So the view, as we know, is a whole nother deal from looking at 2D graphs. There's the view, either profile or map, and then there's the duration graphs. Okay, this is a duration graph. So and then we go at 45, we're at 100, very top of the graph. And then at 55, we're back at 0. So all I got left to do is connect my dots. And don't give me one of these, please. Don't give me the old last second shaky hand, okay? Don't do that. I'm going to give you half credit for that, because that's just slop. We don't need to be sloppy. Okay? Best class I ever had, well, best class I had in, well, I had a lot of good classes in middle school, but drafting was one of them. The teacher was a total jerk, but I fell in love with drafting. My dad's civil engineer, so kind of finally saw those, why he had so many cool instruments, and he'd do a lot of civil engineering on the side too. contract out. You know. Anyway, in his study always had a big drafting table, and I'd go in there and just marvel at this what this guy could draw and how precise he was. Such an engineer. Yeah, you can be inspired by that kind of stuff. All right, and so that's it. There's my Twin Peaks, as we suspected. But now we have it. Now we have the exact positions we need. So in this, one more thing you got to do on this worksheet, and this is not one you're going to submit, but you're going to turn it in with your packet. I keep saying sometime around Thanksgiving, probably a little after Thanksgiving. No, I can't squeeze a test in before Thanksgiving. There's no way. So I don't think, unless I just start slashing and burning and moving. Anyway, so in this area right here, you are supposed to write a little paragraph about some possible scenario, what this might mean. I don't want to give you suggestions because then you'll just write down what I say. So I keep wanting to tell you an idea, but you know, the idea of something going out, coming back, sitting still, going out, coming back, you know. Yeah, it could represent, see here I'm going to tell you, daggone it. Well, it could, don't say this one, but it could, sorry if I steal your thunder, but it could represent playing catch with the dog, right? Because you throw, the dog runs out, you throw the stick, the dog, that's a long stick, or because it's 80 meters, which is like 80 yards. So it goes way out there, and then the dog brings it back, and then sits, and then goes out again. Something like that. Just some kind, don't say that one, though, but some kind of scenario. Or you could maybe choose the profile view, something going up and down. Maybe it's not X, maybe it's Y. Okay. So there's that. That was the main, what we tried to talk about in class on Wednesday. And then the last 15 minutes or so, I did this, we did these together and then went to the board. And so I guess because your idea of going to the board is you doing it on your paper, but let's do the one on the left together. So this is the same thing we've been doing. Now the top two, this is 2.4. The top two on the top half of the page, those are both, you're supposed to plot the derivative graph. So the slope graph. And on the bottom, you're supposed to do the area graph like we did. So there's some coloring involved in both cases. So you will need at least 2 colors. I think there's a couple occasions in here we need 3 colors, but normally it's 2 colors. So first thing I'm going to do, I'm going to color in. We'll do this one together here. And I guess because you're virtual, I guess we'll do them both together. But I want you to do it on your own. If you're just virtual and all you're doing is sitting kind of listening to me and half watching and drifting off, you're not doing it right. You've got to be active. Try and be an active listener. Try and anticipate what I'm going to say. God, that's a terrible one. Anticipate, or, you know, and then get your colors out. I mean, you gotta do it anyway and turn it in. This one as well will not be submitted. We're going to submit 2.1, and we'll submit 2.5. That's the gold standard, but we'll talk about that next week. Okay, so that's supposed to be a right triangle, a little sloppy. That's supposed to be a right triangle. Okay, and so the reason, what am I doing? God. Maybe you noticed what I was doing. You're screaming at the screen, and I should probably edit that out, but I don't know how you edit a Zoom. You don't edit a Zoom, man. You can put it on iMovie, and then a laborious process of editing it out, and it takes forever. So no, I won't be doing that. So you're getting to be raw. That was just, I did this thing 3 times on Wednesday. You know, I'm talking. So there is that. So the reason why I made a mistake is I made it an upside down right triangle. And don't look for this in a book. This is just me teaching 35 years. I mean, it's helped students all the time when they're trying to figure out slopes. They they just ignore the fact whether it's positive or negative, which is like ignoring the fact whether the Dow Industrials are going up or down. It's like just a number. Hey, what did the Dow do today? 400 points. Did it go up or down? But students all the time give wrong slopes. They get their slope wrong. They say it's a slope of 5 when it's really -5. That's a pretty huge mistake. So that's why, to emphasize that, I have, if it's a positive slope and it's rise over run, remember, is what we're looking for. That's what we want to know velocity. So for positive slopes, I make them right side up right triangles. And for negative slopes, like we have, like you have when you go to the board, quote, go to the board, these will be upside down right triangles. And that's one reason why I want them to go to the board. And if you, I don't know if I took a picture of this, but there's third hour, there's a whole bank of students in third hour that does beautiful work on the board. I swear to you, it's some of the prettiest work. I don't know, it's just weird how I randomly set them there, and then you go up there and they just do amazingly solid work. So I keep taking pictures of their work. Anyway, so maybe I take a picture of it. That's in third hour. Now, the good thing is third hour doesn't have to erase the board because there's no afternoon classes, right? I like that. So then I come back on Monday morning, or even if it's a Monday to a Tuesday, I come back in the morning, it reminds me, oh yeah, that's the last thing we did on the board. And same with first hour. First hour benefits from that. For one thing, you get to see the beautiful work of third hour, but another thing is they get to remind themselves, oh yeah, that's what we were doing. Okay, so we are here trying to plot the slope graphs. So this guy rises 7, carve out some space here. This guy's going to rise 7 meters and he's going to do it in 10 seconds. And then I also want to know what the slope is. So I know you can't do this, but this is supposed to be something great presentation here. So it's got to look nice. All right, so 7 meters, 10 seconds. And then the slope then is 7 divided by 10, or 0.7 meters per second. Okay, so now, and then of course over here, this is flat. So the slope of this, of course, is 0 meters per second. Okay, so now down here on this graph, we're going to plot the V versus T, the slope versus time. So it looks like I got 0.7, I got 0. So I'm going to lay that out. I guess I'll do let me find a different color here. I'll do these in dark purple. There you go. All right, so it's all first quadrant stuff. So I go 0, 0.51. I had a student ask me, I said, well, why not? I didn't do that. I just said 1, 5, 10, 15. But the problem there is your graph, if you say 1, 5, 10, 15, your graph ends up taking up a little tiny space down there. And that's not cool. That's really rude to the reader is trying to read and go, what are you doing? So sometimes I'll have kids turning graphs and the graph looks something like this. It goes, and that's the whole graph. I said, obviously, buddy, your scale, man, your scale's way too big. It's a learning process. I'm not laughing at anybody. I mean, it's just, that's the only reason I do that. I laugh because I remember myself doing stuff like that all the time. Just kind of man, I was a knucklehead in high school, just a knucklehead. I think of some of the stuff I did. I mean, just not, I mean, yeah, we did some crazy stuff, but I mean, just in school, just daily in class, like, what was I thinking? All right, so this goes from 0 to 10 seconds at 0.7. So come across here. And then remember, you do that open circle because it is going to compete. This is going to compete with a 0. And I think one student also thought that was very smart of him. Maybe it's Logan or something. Logan had some really good notes. Logan is a doodler. I love doodlers when I grade notes. People that doodle all the time. And they say, they found out that doodling is actually really good for your thought process. And a lot of physicists doodle. You'll see doodles all over their pages. Because while they're doodling, they're thinking too. Their hands are moving. So it's really good to do. Anyway, I think it was Logan or somebody that that said that, I think he said, well, if I put 0 like here, if I put 0 at this point, maybe I misunderstood him. I thought, well, that's brilliant. If I put 0 at this point and then make that 0.5 and that 1 and that negative 0.5, then the horizontal line here is not like stuck down at the bottom of the graph. So once again, like trying to be a better communicator, it'd be probably smarter to put this as 0 right there. But too late. Okay, so over here, so that's what we did. That's what we did Wednesday. And then at the end of class, it was about 6-7 minutes ago, I said, okay, now you go to the board and I want you all to plot this other graph over here, to plot this other slope graph. And so now I ask that you pause. Okay, I'm going to pause. And then you pause, and that's you going to the board. And then we're going to come right back and the thing's going to be done. Okay, so I'm pausing right now. Pausing. Okay, and then now while I'm paused, you do this one. All right, so here's my new rule on going to board problems. And that is, now I've done it, and I'm going to quickly fast forward through it. So you should have done it. If all you're doing is sitting there staring at me, staring at the screen, then you're blowing it. You're blowing it. Because it's like I can sit and watch, I can watch the beard, James Harden, hit threes and just be amazed. But then I don't expect me to hit threes unless I go practice. So you can watch me work problems. Not that you're amazed, but you can watch me work the problem. But until you can work the problem on your own without me, you don't understand it. So that's why this is so important. Go ahead and pause it again if you haven't, and work this problem right here, the one on the right. Now I'm going to go through it quickly. Okay, so here we go. I'm assuming you're checking your work. So first thing you do is you make your negative this time. They're negative right triangles, and I fill those in. Okay, so I've established that there's 2 negative velocities. So something's going backwards at a slow rate and then continues to go backwards, but like throws it in gear or goes backwards. That's not correct. They're coming back to the origin. And so maybe they're in first gear for the first 20 seconds, they kick it into second. And then from 20 seconds to 38 seconds, they go a lot faster. Now they're not speeding. They did do a change in speed, but the speed is 2 constant speeds. Right? We're not really. I shouldn't have said that. Speeding up sounds wrong, but they do have 2 different speeds. Okay, so let's keep going. So then I went through and I whited out space for me to write in the numbers. Well, that's 20 seconds, and that is -2 meters. And so then this was 18 seconds. And then this was -11 meters. So then we have to divide those out to get my slopes. And so my velocity, my slower velocity here backwards is -0.1 because it's 2 divided by 20. So -0.1 meters per second. And then my other one is -11 divided by 18 or -0.61 meters per second. So I sped up, 6 times the speed. Okay, so hopefully you did that. And then now we got to plot this down here. So I'm going to pause it again and I'll set it up and then I'll quickly go through it. Way to try and speed these things up a little bit. All right, back from pause. So hopefully you did the bottom graph. I'm now going to fast forward through it. briefly talk about things. So I established my 0 there. It makes sense. We're in the 4th quadrant mostly. I went ahead, you want to thicken in your line that separates the 1st and 4th quadrant. Now, in 1st semester, we're only dealing with pretty much up till January, we're only dealing with 1st and 4th quadrants. We get into more springs and stuff. We get into the 3rd and 4th, 2nd and 3rd. But mostly 1st semester will be in the 1st or 4th quadrant. So anyway, so we thicken in the line there. It separates forwards and backwards. And okay, so we got to establish our scale. This is probably most appropriate scale. All right, and then and I see I messed up here. I forgot to label it. Oh, it's already labeled meters per second. Okay. So then you just write in your lines. That one's -0.1, stayed constant in the interval, open circle at the end. And then we have -0.6, and that's it. I mean, you're done. So we're going to stop there. Now, what we'll do, if you want to do the area graphs, you can. We're going to do those on Monday. And then we're going to do, so for Monday, we'll do the area graphs. We'll talk about the back, and that's that dance I talked about earlier in the presentation. So we'll be doing some dancing, or I'll give you the opportunity to dance on Monday, and really all the way till you have all the way to November to do that. Maybe they'll be in the packet 2 for extra credit. We'll talk about that more. Okay, and then we'll start. We'll do a problem off the 1.5, which is gold standard, and I'll assign that as homework. So now we're finally out of packet 1. It's gone, except for the blue and black days, blue and black time, blue and black problems. That's about all. That's the only remnant left of packet 1. So yeah, now we're full-fledged into packet 2. We'll speed up the work on packet 2. On Tuesday, like I say, we'll probably be in the hallway in a handicap ramp between the science building and the library. We like to go outside, but my guess is probably Tuesday it'll be too cold. That's okay. So we'll do the handicap ramp. And then that will lead us to our first trio. And then once we get into trios, now we're finally getting into orange world. We can finally, for once and for all, get out of red equations and black. Well, you never get out of black equations. But you can finally stop talking red all the time and go to orange. Orange is much more interesting. Okay, so yeah, thanks for listening. And we'll stop this. So stop sharing. Okay, so anyway, thanks for listening. And I'll see you guys next time.